Today we're going to look at exponential and logarithmic modelling, and these questions can get quite wordy, but modelling of course means that they're related to real life situations. Exponential and logarithmic means we're looking at using indices and also logs along the way. Here's my first example. We've got an equation here, d equals d naught e to the power of kt. D is the number of cases of disease, t is the time in years. K, you might be wondering what that is. K is a constant which we'll have to find at some point in this question. Now d naught, though not specifically said in the question, that d naught there usually indicates the number of cases of disease at the start, at time 0. Also told that using the available medication, the number of cases is being reduced by 20% each year, and there are 10,000 people with the disease today. The first thing we're asked to find is d naught. Okay, and to find that, we're going to substitute in some of the values that we know. So if we're going to find d naught, what we know at this stage is that, and as we know, as I said, d naught is the number of cases at the start. Okay, now we're actually told there that the number of cases, people with the disease today is 10,000. So we can be pretty safe that the answer is going to be 10,000. And if we're putting our values down, so the number of people with the disease that we know about is 10,000 and the time is 0. Okay, we're trying to find d naught. So d, if we write the equation out again, d equals d naught e to the power of kt. We know that at time 0 there are 10,000 people with the disease, so 10,000 equals d naught e to the k times 0. And of course anything times 0 is 0, should be 10,000, so 10,000 equals d naught e to the power of 0. K times 0 is 0, so therefore 10,000 equals d naught times 1. D naught times 1 is d naught, so we stand to reason that d naught equals 10,000. There's our answer for d naught. So we've confirmed there that our value of d naught is 10,000. Okay, so, and as I said, d naught, in any of these questions, d naught, t naught, whatever, usually means at the beginning, initially. And we're actually told that, but anyway, we've confirmed it. Next one is find k to 3 decimal places, and then write the equation substituting k and d naught. Alright, we can now rewrite this equation, because we now know that d naught is 10,000. So with that equation there, we can now write it as 10,000 e to the power of k, kt. There we go. So that's the new equation, and now we've got to find k. Right, now how are we going to do this? Well, we need to do a bit of substituting here, and we're told that, if you look in the question here, that the number of cases is reduced by 20% each year. Alright, so we can find out the number of cases after 1 year and substitute it in. For example, after 1 year, if they're reduced by 20% each year, well, 20% of 10,000 equals 2,000. So after 1 year, okay, you're going to get 8,000 people. So in other words, when t equals 1, the number of people with the disease will be 8,000. We can use that piece of information. Okay, so d equals 10,000 e to the power of kt. So we can go 8,000 equals 10,000 e to the power of k times 1. So what I've done there is substituting the value of d and the value of 1. So if I divide through by 10,000 now, 8,000 over 10,000 equals e to the power of k. 8,000 over 10,000 will be 0.8 equals e to the power of k. Got that equation there now, 0.8 equals e to the power of k. That can now be solved on the calculator. Solve 0.8 equals e to the power of k, and you get the answer there of k. K equals 0.223 to 3 decimal places. Now in the book, these questions, they like to do them using logs, and I might just show you that as an alternative way of doing it. But using logs, you've got to use a calculator eventually anyway, and what it really does is just to add a few lines to the sum. So I'll just keep that there for the moment. So that's the calculator solution. But if we were to use logs, so we go from this step here, and what you do now is you log both sides to the base e. So whatever you do to one side of an equation, of course, you can do to the other. So if I do this, now there's no problem with doing that. And then log 0.8 to the base e equals, if I bring the k out the front there, I get k log e to the base e. So what I get then is, because log e to the base e, because that is 1, I just get k times 1, and it just equals k. So there's my solution for k. Then I can get on a calculator, which I have to do anyway, and I go ln 0.8, and if you do that, you end up with the same answer here anyway. So in my mind, unless you're specifically asked to use logs, and you've got the calculator available, from this point here, it's just a matter of solving it. Alright, we just found that k equal negative 0.223. Just realised as I was doing that I should have had the negative there, sorry. So if you're doing that on the calculator and wondering why you're getting it wrong, it was k equals negative 0.223. Okay, so the formula now becomes D, this is answering question C, 10,000 to the power of E, and now we know that K is negative 0.223, we put negative 0.223 times T. Okay, so that's now the equation that we can use for the remainder of this question. So the next question is, how long would it take for the number of people with the disease to be halved? So from now on, we're going to use our new equation. There it is, we just worked it out. And of course, for the number of people to be halved, we started with 10,000. That means we are going to use a value of D equals 5,000, because that would be half of 10,000. And the time is what we're looking for. Okay, so let's place the 5,000 into the equation here, and we get 5,000 equals, and then it's just a matter of putting in the right hand side of the equation. Equals 10,000 e to the negative 0.223t. Okay, then we can divide through by 10,000. So 5,000 divided by 10,000 would be 0.5 equals e to the power of negative 0.223t. Okay, so we can go for our calculator now if we wish and work that out. Menu algebra solve. Here's the strategy here. And solve 0.5 equals e to the negative 0.223t comma t. And we get t equals 3.108. So that would be approximately 3 years. How long would it take for the number of people to reduce to 100? Okay, same sort of strategy as before. So this time our population is now reduced to 100. So it's 100 equals 10,000 e to the power of negative 0.223t. And we can solve that on the calculator. Now this time I'm going to do it a little bit different. Instead of solving it, I'm going to use logs once again, but just to give you that alternative method. How do I get 0.1? 100 divided by 10,000 is 0.1 equals e to the power of negative 0.223t. Okay, so now I can log both sides. So logging both sides. Go up here, and then I mentioned how you can get that on the left hand side, and you can bring the this one out the front, okay, and multiply it by log e to the base e, which is 1. So you effectively get, when you do that, you effectively get 0.223t. Then you get t by itself. You divide the left hand side by the coefficient there, which is negative 0.223, and you should get, I've made a mistake here because that should have been, beg your pardon, that should have been 0.01. So just I'll replace, I'll just pause for a moment and replace all my 0.1s with 0.01s, just a moment. Apologies for that. 100 divided by 10,000 is 0.01. Not 0.1. So anyway, work through till we get to there. So we get log 0.01 to the base e over negative 0.223, and that's going to equal our answer, which is 20.651. So it's approximately, to the nearest year, about 21 years. So in those last two questions, I've given you two alternatives there. In this one here, we just plugged in the calculator like so. Okay, remember we've got a calculator available, so we can do that. But I always still like to show people how to do it using logs as well. And I've showed you with question E how to do that. Next question. A cup of soup cools to the temperature of the surrounding air. Newton's law of cooling can be written as T minus Ts equals T naught minus Ts times e to the power of negative kT. Some definitions. T is the temperature of the object after T minutes. Ts is the temperature of the surrounding air. Now it hasn't actually defined here T naught, but we can say that T naught, okay, is initial temperature. Said before that the 0 or the naught means initial. And we're told here the soup is cooled from 90 to 70 after 6 minutes in a room with air temperature of 15 degrees Celsius. Now, I haven't looked at the question yet. In fact, the question asks the values of Ts, T naught and T, and K to 3 decimal places. Well, let's have a look here. T is the temperature of the object. Okay, so that will we have to find that out later on. But Ts, okay, is the temperature of the surrounding air, and that's going to be 15 degrees Celsius. So Ts is 15 degrees Celsius.
I packed everything out of my...
Ts is 15 degrees Celsius. T naught, as I said, is always the temperature at the beginning, and temperature at the beginning here is 90 degrees Celsius, and we're asked to find K to 3 decimal places. So let's see if we can do that. Alright, so let's apply the formula, and also we're not asked it, but the final temperature, the temperature after T minutes here, is going to be 70 degrees, and it happens after 6 minutes. So t equals 6 minutes. Okay, so let's see where I got those from. Okay, temperature of the surrounding air was there, 15 degrees Celsius. Temperature at the start, initial temperature is 90 degrees Celsius. Temperature at the end, 70 degrees Celsius after t minutes, and the t minutes is 6 minutes there. So that's where I got those different things from there. Okay, let's proceed into the question and find out the value of k. I'm going to substitute everything here. Okay, so 90, which is, sorry, not 90, 70, which is t, minus temperature surrounding air, which is 15, equals t naught, which is 90, minus ts, which is 15, multiplied by e to the negative k times 6. So if you look at the equation up there, I've substituted all the values in. Okay, I'm asked to find k here. Let's simplify it. 70 minus 15 is 55. Equals 90 minus 15 is 75. E to the negative 6k. Divide through by 75. 55 on 75 equals e to the negative 6k. Okay, so we can now solve this in the calculator. Very important here that with the 55 on 75, if you do it there, you bracket that. Or you can work out what 55 on 75 is, and can solve it from there. You can solve it from all sorts of places. You could even solve it from back up here. Okay. Now if we do that, we get a value of k to 3 decimal places is 0.051 is the answer to that one. Okay, so k equals 0.051. So there's the answer to that one. Okay, next up, write the equation. Oh, sorry, we've done that. Oh, no, we haven't. Write the equation substituting the values of Ts, T naught, and K. Alright, so the equation is now T minus 15 equals, now we know T naught is 90, minus 15 is 75, e to the power of negative 0.051 t. So I've substituted in the new values. There, so we can use that equation from now on. Let's look at the next question. So we'll use that equation now to answer this one. Find the temperature of the soup after 10 minutes. In fact, I could probably tidy this up a bit better, because I can now say, this is probably the answer I should have put originally, that t equals that plus 15. In fact, in hindsight, I should have taken the 15 across and done that right from the start. So there's the equation for working out the value for t. So if you're looking for after 10 minutes, so t will equal 75 e to the power of negative 0.051 times 10 plus 15. All I've done there is substitute t equals 10 for the time, and we want the answer to the nearest degree. T will equal 60 degrees Celsius. How long will it take for the soup to be 40 degrees? Give your answer to the nearest minute. Okay, so this time we've got to find t. Oops. Might just copy across this equation here. That's the one we'll use. Let's get rid of that. Those there. Okay, so we use this equation. Now we know t is 40 degrees. Okay, it's been identified there. So 40 equals 75 e to the power of negative 0.051t plus 15. Take the 15 across, we get 25 equals 75 e to the 0.051t. Divide through by 75 if we want, or we can solve directly from there. So we can go solve 25 equals 75e. 75e to the power of 0.051t, comma t. And our answer there for this one will be 22 minutes. Okay, answer to the nearest minute. Next question. If the soup is placed in a fridge in which the temperature is 2 degrees Celsius, how long will it take for the cup to reach 40 degrees? Use the same value for K. Give your answer to the nearest minute. So a few of our values change here now. Our final temperature T, so we're going to refer now back to this original equation. Okay, but we do know that K is the same as before. So K will still be 0.051. That won't change. So we'll use the original equation. So T is 40 minus temperature of surrounding air, this time it's 2, equals, in brackets, so the original temperature still the same, is 90 degrees, because remember that was the temperature at the start there, minus surrounding air temperature is 2, e to the power of negative 0.051t. So that means 38 equals 88 e to the negative 0.051t. Okay, so solve. 38 equals 88 e to the negative 0.051t for t, and you get t equals 27 minutes. Please try those things on your calculator, make sure that I'm getting it correct and that you've got the calculator skills all worked out. Okay, next question.